Hi, thank you all for joining us today. I'm Adria Wheaton, and Candace Scheibel is also joining us too, and it sounds like her internet just died at an inopportune time. So I'll just introduce our speaker today. We have Tim York from Aurora, Colorado, and he joined Aurora Water as a water conservation specialist in 2012 to perform irrigation plans, review for private developments within the city. And prior to working to Aurora Water, Tim worked in the design, construction, and site development field for large-scale projects in Las Vegas, Nevada, and San Antonio, Texas. Sounds like he's been in a lot of arid environments. Tim has a Bachelor of Landscape Architecture degree from the University of Nevada, Las Vegas, and he's a registered landscape architect in Colorado. His current position is a division supervisor for Aurora Water Conservation. So with that, I will turn it over to Tim.
So we're going to start this off with just a quick survey to try to get an idea for where everybody's coming from a sector standpoint, where your profession kind of lies within the field.
Okay, so I've launched that poll. Attendees, you should see that. We'll just take about 10 seconds to give you a chance.
All right, so it looks like over half of you are in the same position I am, working for the public utility. So this should be great. It's really geared towards the public utility and what we did in respect to this program. So let's go ahead and get rolling. So really this pilot came out of a question we asked ourselves. We've been dealing with contractors for a number of years, and I'm sure you've all heard it. They really want to put in these smart weather-based controllers. And one of the issues we had as a utility was that they really weren't being managed. We got a lot of contractors wanting to sell them to their customers with really no guarantee or no idea of a management plan. It was really just kind of a material sales. Hey, we want to upgrade your controllers and you'll save a bunch of water. So what we wanted to do before we implemented anything from an incentive standpoint was we wanted to do a pilot just to kind of get some ideas of how they would perform in our region under a couple different scenarios. So you can see on the screen there was 3 scenarios that we wanted to approach. The first one is kind of that standard set it and forget it, where a contractor upgrades or sells an upgrade for controllers to their customer, plugs them in, really doesn't do much to them. Most utilize the default inputs for precipitation rates by head type, maybe doing the manual input for soil and the sun exposure, simply just walks away. That's normally what we were seeing in the field. We weren't seeing much savings from them. We weren't doing a lot of research on them either. But we wanted to kind of use that as a basis to see what more we could get out of looking at a couple other scenarios. The second one started to build in that controller management. So this idea of irrigation management. We are seeing a big growth in the irrigation management sector from a business model in our region to where companies are now focusing solely on irrigation management. So what we wanted to do was have the smart controller installed, program all data based off of an assessment or an audit. So our team in-house went out and performed that assessment so that we could provide data for inputs into that controller. In the third scenario, which is installing the controller using management, but also upgrading all of these zones within that scenario, that area of the property to kind of match what our current rebate at the time was. And it was really bringing it up to our city code. So we wanted them to install all pressure regulated heads with check valves, high efficiency nozzles or low flow nozzles, and also provide that full controller management for 2 growing seasons. So this whole pilot was a 2 growing season pilot. It extended from 2015 through 2016. And as we get through this, you'll kind of see where we ended up, what data we were able to gather, projected savings or actual savings for those properties, and what we were able to do with that data. So just a little background on Aurora, Colorado. If it looked like most of the participants were from the southwest and west, a lot of California and Utah. Seems like we're all going through the same struggles from a water standpoint. In case you didn't know, Aurora is not in the mountains of Colorado. It is not full of beautiful pine trees and a bunch of snow. We are a prairie city. We're about 5,500 feet in elevation, just to the east of Denver. And on average, from a plant water requirement for our cool season turf, which is Kentucky bluegrass predominantly here in the Colorado area, we see about 28 inches of supplemental irrigation as an annual need during the growing season. That can vary substantially. In 2016, we saw a 30% increase. I do have a slide that shows some of that weather data by year. And our weather, like those of you that were in St. George, the southern Utah area, can really vary. Our highs get up into the 90s, and our lows can get well below zero. The lowest in the 6 years I've been here is -17. So a big variance in weather. It's fairly consistent from year to year. If you look at a 5-year rolling historic average, we always tend to end up around that 28 inches of water per growing season for cool season turf. But that is shifting, and it's shifting up. We have about 360,000 people, just over 85,000 connections. Most of those are residential. We have a small industrial and commercial sector, but we are primarily a suburb city of Denver. And our storage capacity is about 3 years worth of storage. So we are predominantly surface water. We have 12 reservoirs. 95% of our water supply comes from snowmelt. So very dependent on snowpack. For those of you that are also getting water off the Colorado River system, I'm sure you've noticed what the snowpack has been this past season. So we are very conscious of what's going on up in the mountains. So the history of our rebate program, and the reason why this is important, was this pilot was really built to influence our rebate program. So in the past, our rebates were really based off of component upgrades in the system. So heads, nozzles, and rain sensors were really the top three. For customers to be eligible for any irrigation incentive from us, or any irrigation rebate, they do have to go through our free irrigation assessment or irrigation audit program. We changed the name from audit to assessment just because it sounded a little bit friendlier. We do about 290 assessments a year. We contracted that out until 2013. And in 2014, we decided to bring that all in-house. So we currently do all of those with summer staff that we hire and train. And the reason why we made that change was really to start building this customer relationship early on. When we were contracting out, it wasn't that the assessment wasn't done good. It was that you didn't have the ability to engage with the customer and have the customer know that it was somebody from the utility from the start. So that as they worked through the process of the assessment, the audit, and the rebate program, they were always dealing with the same group. So if you look at the one slide there, the one graph, since we've taken this in-house, we have seen a pretty steep increase in our irrigation rebate participation and dollars spent. And I do have a slide at the very end that shows 2017. So it has continued to go up. Another thing that's important about our irrigation assessment program, when we brought it in-house, we decided to break it up into 2 phases. So if you're familiar with irrigation audits and the standard kind of catch-cup methodology for determining distribution uniformity and net precipitation rate, when we were contracting it out, that was all done in the first phase. And one of the issues we ran into that is that you're going out to a customer's house and you're giving them this precise data based on catch-cup readings for their system, but then you're asking them to change their system. You're asking them to upgrade it and change their components, to which now that data is no longer valid. So we decided to break it up into a 2-stage process. Stage 1 is more of a visual inspection of the system. We record controller programming, watch the system run each zone, get an idea of what kind of components they have, record that. And we provide them with a report. It's usually about 8 to 9 pages. And from that report, it would give them that list of recommended repairs so they can make those upgrades. If they did choose to upgrade their system so it was more efficient, we would then go back and perform that stage 2 assessment for them to give them that data for a system that's now upgraded. At that time, the smart technology, the controllers, moisture sensors, they were available as part of the incentive program, but they always seemed to fall to the bottom of that recommended repair list, or that kind of hierarchy of things that needed to be changed out in order to get their rebate. So we didn't see too many converted there, which is one of the reasons why we wanted to do this, to see if we could increase the value or the priority of those smart controllers. So the pilot parameters, we chose one property here in Aurora. We were able to work with a local irrigation management company who, that's really all they do, is manage irrigation systems. So we selected a property. We were able to map all 3 zones to get the vegetation cover for high water use and low water use. We also, or the contractor did this part, we had mapped all of the irrigation heads within the 3 scenarios. So looking at this image, the bottom section that kind of has that red reddish pink hue to it is scenario 1, the green is scenario 2, and the blue is scenario 3. We performed an irrigation assessment for all 3 zones, and after that assessment, before we started any data collection or upgrades, we had them repaired. There was a few broken lines we found, and we also wanted to do flow analysis. One of the lessons learned, I don't have a lessons learned slide, but one of the lessons we learned on this property was we had, for scenario 2 and scenario 3 combined, we had some meters that overlapped both of those areas. So using the actual city meter, we did flow analysis for every zone so that we could use those run times later to determine actual water output per zone. We gathered all the data from precipitation rates, DUs, sun exposure, wind exposure, soil type, so that we could put that into the controllers for scenarios 2 and 3. For scenario 3, again, all heads were upgraded to pressure regulating stems and check valves and low flow NP rotator nozzles. These are the controllers that were used, ET Water 205W 24 station controllers. It's just a picture of the meter that we pulled the flow data off of. We also did monthly images throughout both growing seasons to look at turf quality. We wanted to make sure that if we were seeing a reduction in consumption, that we weren't overlooking the health of the landscape. So we did monthly pictures of each scenario. We took 3 pictures of the exact same area every month. And all in all, at the end of the day, the turf quality remained fairly consistent throughout all 3 scenarios, even though the water use was substantially different. So the contractor for this pilot was responsible for the irrigation controller installation, system management, in-ground upgrades, the initial flow data they provided to us, and they also had to provide us the monthly runtime reports for the controller so that we could do our analysis. The only thing we had to do, this was a very easy pilot from a utility standpoint, provided funds, which we'll talk about here in a minute. We did the images for the turf quality and health and the monthly and season end analysis. So there was very little man-hour time or staff time that went into this pilot once it got started. For weather data, we're set up with, we have 5 weather stations that are located around the city. And to stay consistent with how we currently do recommended water use, we decided to go ahead and continue using all 5 weather stations and pull average numbers. The chart you see is something that we typically do for our customers if asked. It is a 7-year history of their water use. We were able to put in their landscape square footages by type. We just upgraded this to simplify it and put in less types, but essentially you can put in cool season turf, full sun, persistent wind, or whether or not it's sheltered. It'll go back and pull all the consumption data for the past 7 years. We also have weather data for those years built in. And at the bottom, it will give us how they've done, how much water they've used in comparison to the recommended water use based on their landscape types. These are the 5 weather stations that we have around the city. We don't owe them. We do pay a contract for the data, which at times has been somewhat of an issue. You can see the yellow dot there. That is a property location. So we're not really right in the middle, so it's best to use all 5. Typically, when we look at our annual weather data across all 5 sites, evapotranspiration numbers tend to stay fairly constant. That southeast one there that you see will usually be a little bit higher. There's a lot of construction going on out there, but it's, if you've been on the plains east of Colorado, it's very flat and windy, and there's no trees, so it gets baked pretty good. Where we really see the difference in values is the precipitation rates. Just the way the storms roll through here, that southeast weather station can get 2 inches of rain in a couple days, to where the one just north of it gets 0. So it's kind of important for us to average these numbers out and be consistent with our current methodology that we use for any customer within the city. So just a little bit more on weather data. As I mentioned, when we do our 5-year averages, it tends to stay fairly flat around that 28 inches of water. But you can see here just the variability in seasons. This year we came in a little bit lower than 2016. We were right about 34 inches. So it does change every year, which really kind of pushes us a little bit more towards these smart controllers as well. If they're going to offer us the benefit of adjusted schedules based on true current weather data, there's definitely some potential there for some reductions in consumption. So the funding was all paid for by the utility. The total customer cost, including management fees and labor, was about $32,000. What we were willing to pay for, to kind of take it back to most of our incentive programs, we only pay for materials. We do not pay for labor, and being a government agency, we cannot pay for taxes. So the agreement with them was to pay for 50% of the controller cost upfront after install, another 50% at the end of the second growing season. And the reason we did that was we wanted to make sure that we got the data. So there was really a contract between us and the irrigation management company, and essentially the property management company, who's the one who got the funds from us, that if they provided all the data on time each month as we had requested, they could get the rest of their funding regardless of how they performed at the end of that second growing season. We also paid for 100% of the material costs for the head and nozzle upgrade in scenario 3 that I talked about. So our portion of it was just over $15,000, right at $15,600 for the entire rebate pilot program as far as utility funds go. So how did it go? We're pretty, when we talk about conservation here at Aurora Water, we really want to focus on efficiency. So I know there are conservation groups out there, and maybe your region is kind of this way, where really the focus is always about using less. And at times a severe drought, I definitely understand where that's coming from. But when we're looking at these programs, we really want to make sure that we're driving towards efficiency. We do have properties that use less than what they should. It is very rare, and those others of you that are in the municipality side of it probably can agree with me. Those that use less is rare, but in those cases, we don't really want to tell them that they have to use less water, or if they're using the amount they should be using, they're right at that recommended water use. It's not really fair for us to say that you should be using less under normal conditions. So when we look at how we did, what we were really looking at was a change in percent of recommended water use and trying to get a trend going down towards that 100% of recommended water use or plant water requirement. So for 2015, and you look at the 3 scenarios on the chart on the left, scenario 1, again, is that kind of set it and forget it. The controller went in, the normal inputs from the controller were not really modified, no management, and we actually saw a 32% increase in regards to plant water requirement in that first growing season. We saw substantial reductions for scenario 2 and scenario 3. Both had that management aspect to them. What was interesting to us was that we had been following this model of upgrading the rest of the components in the system as being the number 1 priority. And what the data started to tell us was that even though we saw an additional 9% kind of shift towards that plant water requirement, that change wasn't nearly as significant as just the controller management side of things. So if you look at the chart on the right, the orange line is the 5-year median. So this property before 2015, the 5 years prior to that, they had averaged, or their median operating was about 155% of the recommended water use. The green line is 100. So you can see that trend's finally starting to move down towards that 100% mark, even just in that first year, except for that scenario 1. As we get to 2016, we see a bigger decrease, and it's across the board in this case. 16% closer to recommended water use, even for scenario 1. And then if you look at the chart on the right, we got really close to 100% for scenarios 2 and 3. What is interesting there again is that in the first year it was a 9% kind of increase towards efficiency between scenarios 2 and 3. In 2016, it was 11%, still not very substantial when you compare it to the increase in efficiency that we're getting in regards to plant water requirement versus water applied from installing the controllers and actually having them managed correctly. We think that the reason that we saw the increase, I'm going to go back one slide, the 32% for scenario 1 increase down to a 16% decrease, is if we go back to that weather data, 2016 is where we saw a 30% increase in plant water requirement. So this is starting to kind of show that maybe in those even hotter, drier, more drought-style years, that the controllers have an even better or higher impact on water output versus the plant water requirement. So we had a question come through. I'm going to go ahead and we have two questions. I'm going to go ahead and answer them before we move on, just to clear things up a little bit. The first one is asking, did we give participants some sort of water discount or adjustment in cases where the water use increased? No, we did not. The customer signed a contract knowing that going through the pilot program in some cases may increase their water use. So we were pretty upfront about that and spelled that out in the agreement. So they did not come back asking for a deduction. They were getting the incentive up front with hopes that this data would help them in the future once we got past the pilot and they couldn't manage those other, that scenario one controller, that they would see a reduction. And the second question is to remind you again of the 3 scenarios. So scenario 1 was installing the controller using default controller inputs, which come with a controller. You basically select the head type and it builds a precipitation rate for you. And then just letting the controller do its thing on its own. Go collect the weather data, and no one kind of adjusted it on a weekly or monthly basis to make those fine-tune adjustments. Scenario 2, controller was installed. The data from the irrigation assessments was used for the controller inputs, and it was managed on a regular basis to where the irrigation management company was out there fine-tuning the system. Scenario 3 had the same controller set up as scenario 2, to where the inputs were based off of the assessment and it was managed. And scenario 3 also had the system component upgrade. So all of the heads were changed out to include pressure regulation and check valves, and they were also put in the low flow nozzles. All right, I got hung up there a little bit. There we go. So return on investment, we really wanted to look at the return on investment for the customer. This is not the return on investment for the utility side, which we obviously calculate a little bit differently. But we wanted to see if we were going to offer this as a rebate, exactly how would it be received, and how could we market this in a way that the property management companies would be receptive. If they're going to output some money, how long is it going to take to get it back? So scenario 1, in all 3 scenarios really weren't bad. Scenario 1 had a return on investment of 1.84 years. Scenario 2 was right at a half a year, 0.56 years. Scenario 3, the interesting one, going back again, which really started getting us thinking about how we were previously doing our incentive programs, had the longest. It was 3.26 years for the property to actually recoup their portion of the money that they had spent. So this does take into account the incentive that was given for the pilot program. So this is just based on their out-of-pocket expense and how long it would take to get them back. So the theoretical water cost without the upgrade was done by looking at that 155% plant of recommended water use. That was their 5-year median, and then assigning that to 2015-16 values to see what they would have spent if they would have continued on that pace. 2016 water cost was their actual water cost, and then the pilot cost was what was out of their pocket. So there's a couple more questions up here. See if we can answer these as we go. You're welcome, David. So the question is, what kind of fine-tuning done to the controllers in scenarios 2 and 3, and how carefully were inputs put into the controller in scenario 1? So for the first season, the irrigation manager was out there bi-weekly looking at the landscape. So even though we put in, and I've run into this situation myself using smart controllers, even if you put the parameters in that the controller allows you to put in, so distribution uniformity, precipitation rate, soil type, sun exposure, it can still overwater. In some cases, it can still underwater. So what they were out there doing, they were looking for wet spots, moist spots, dry spots, and adjusting the controller to compensate for those. The simplest way to do that is you can adjust the precipitation rate so that the controller thinks that it's either higher or lower than what you actually found with your data. As far as how carefully the inputs were put into controller in scenario 1, they were put in carefully from the standpoint of what head types there were, and then the soil type was put in it, and that was it. So there wasn't a whole lot of room to mess that up. So I hope that answers your question on that one. So this seems to take a second after I answer a question to catch back up to me. Let's see if this slide changes. There we go. So the impact of the new program based on the changes in efficiency or the changes in a trend towards the actual plant water requirement or recommended water use allowed us to start to think about a smart controller program, a rebate program that wasn't tied to an irrigation assessment first, and it also wasn't tied to upgrading the rest of the system. Since we saw that increase in return on investment in that scenario 3, and a little bit extra savings or a little bit better trend towards efficiency, it still wasn't large enough for us to be able to say, hey, look, if you want to do smart controllers, you can, but we're going to make you do all of this other stuff first. That's going to lengthen out your return on investment, and you may not see the savings increases that you think you will. So we broke it up into 2 sections, just like most of our incentive programs are. For residential, we'll give them up to $300 max, up to 100% of the cost of the controller. So if they spend $300 on a controller, they have the potential to get it all back. If they spend $350, they have the potential to get $300 of that back. They get 50% at the time of install. The rest is paid over 2 growing seasons. We're really kind of making a trend towards performance-based incentive programs. So we want to make sure that they're not doing what happened in scenario 1 and just putting it in and walking away. We want to make sure that if we're going to give them money and incentivize them to install these controllers, that they're actually taking the time to manage them. Granted, this only goes out 2 years, but there's really no way to to manage it on a 6 or 7 year cycle. So 50% at time of install, 25% after the first growing season if the metric is met. The metric that they have to meet is 110% or less of the recommended water use. If they meet that for the 2 seasons, they get 25% each one of those at the end of each one of those seasons. So really, they can get the controller for free. Most of the smart controller rebates that we processed this past year, if they meet that, they will get the full cost back. On the residential sector, most of you probably know that the options have really expanded, and they're kind of in that $250 range and down. So we should be seeing a lot of rebates where we're covering the entire cost. For the commercial large properties, so anything that's not single-family detached, they can get up to $15,000 total, and the payments are broken up the same. So it's still performance-based, 110% or less of that recommended water use to get those last couple payments there. We have ventured into some custom rebates for some large commercial properties. We did one smart controller rebate at the end of the season this year. That was a total of $56,000 in incentives, so they got 28 of that up front. And then they have the option to get the rest of it over the next 2 growing seasons. So, this was really our first season that we had this rebate as a standalone, which unfortunately means we don't have a lot of data yet on how it's going to perform. But we're hoping after the next 2, 3, 4 years, we can really see how viable this is and really see if customers are, really managing these controllers. There was a Southern Nevada smart controller rebate that happened years ago. And one of the things they found out was that at the time, smart controllers, even for the residential sector, were subscription-based. And so the customers would get the rebate, put in the controller. It typically came with a 1-year subscription. But after that ran out, they weren't updating their subscriptions. So what we're really hoping is now that most of the residential smart controllers are not subscription-based, it's a one-time purchase for the customer, that we'll see a little bit better performance in that sector. So this is what's happened. 2017, again, the first year that we've had this rebate as an option. You can see how much our rebate program has increased. Our best year prior was just right around 60 rebates. This year we almost hit 250, and our spending went up over $70,000 just for 1 season. So it's really being embraced by the citizens, by the community. We hope that it continues. We think it will. And again, we really just I'm interested to see what the data shows in a couple of years and see if this trend continues, and if the savings really is there like it was in the pilot program. So I'm going to go ahead and answer a couple questions. That's it for the formal. All right, so we got 4 questions, and there's some chats too. isn't quite working for me, Mark.
I can read. Do you need me to read you the questions there?
I don't know. Let's see. They were coming down before, but.
Okay, so Brad Jepson asks, how big is your customer base for this project?
Just for this project, pilot was a single customer that happened to have a large. It's a townhome community. It's condos, but they're not stacked, so they're kind of like townhomes. And it was a site that allowed us, because of how it was broken up, to divide this into the 3 scenarios. So for the pilot program, it was just the one customer, the one site.
And then your customer base in general for the Water Conservation District?
Oh, we have about 87,000 accounts.
Okay. And we've got another question here. Disparity between sites using the 5 weather station data versus on-site weather sensor data, i.e. Climate Logic, Weathermatic, and SolarSync?
Yeah, it was actually kind of high, which was really surprising to us. The reason that we decided to stick with the 5 stations instead of using the on-site was that was how we were measuring the historic. So we couldn't really go with the historic being from 5 stations and the pilot program years being the on-site stations. But when we did look at the on-site stations, they were closer to the plant water requirement, even in the 2015 season. So there is some disparity. It's something that we've actually been dealing with a few years at looking for other options for weather data. The way we're set up right now, sometimes we'll have one sensor on a station go down and not know about it for a while until it pops up when we're doing some analysis. So there are some issues with that. Definitely on the on-site versus citywide data disparity.
Okay, got a few more questions here. A few from Thomas. What kind of fine-tuning done to controllers in scenarios 2 and 3? And how carefully were inputs put into controller in scenario 1?
So that one I answered a little earlier.
Oh, okay, I'm sorry.
Oh, no
He's got
worries.
a couple more here from Thomas as well. How involved was the contractor, and what contract negotiations did they have with the property manager?
So the irrigation manager was really involved. The company's called ET Irrigation. They're out of Lakewood, Colorado. Very involved, as they are with most of their sites. Again, they were there all the time, looking at how the controllers were performing. Did we have spots that were being overly irrigated or spots that were being underwatered, and making those adjustments for scenarios 2 and 3. As far as their contract with the property management company, it was a normal contract like they would normally put out there for the controller upgrade, the component upgrade, and the management. They had actually taken over that property at the beginning of that year, so they had a contract in place for site management. So they basically just wrote a normal contract with the property management company. They furnished that to us so that we had the material costs that they were going to be charging the property management company for deriving the incentive amount.
Okay, thank you. Oh, another one follow-up from Thomas. Also, why do you think water use decreased so much in scenario 2 from first year to second? I'm wondering if once smart controller is calibrated ground truth, it could then be closer. It could be closer to set and forget.
Yeah, you're right. The idea that once it's calibrated after that first couple seasons, you should be able to do a lot less manual inputs to it. That's kind of the idea. You shouldn't have to be out there fine-tuning it every year once you spend a season or maybe even 2 really getting it dialed in. So yeah, I completely agree. The idea isn't that they have to be, that the irrigation manager has to be that involved for years on end. But definitely at the beginning, and the data kind of shows that if they spend a season or 2 out there really fine-tuning it, and after that don't really make any changes, to the rest of the system, they should be able to almost set it and forget it. As long as they're doing, we recommend checks just to make sure everything looks like it's running right. Luckily now, all of these controllers are web-based, so the irrigation managers can really see what they're doing from their computer, look at all their sites, especially if they're using the same controller across multiple sites. It's very easy for them to check. and they should be able to drastically reduce their on-site time.
Okay, thank you. We have another question. For scenario 2, could similar results have been achieved with active management without a smart controller?
Yes, that's a great question. I'm glad you guys bring that up. So when we started this, or when I started here, and we weren't giving incentives for smart controllers before they did all the other things, that was really our mentality, was you can do this without a smart controller. It's going to take a lot more work, and it's going to take a lot more time. The truth of the matter is these properties aren't paying, and they're not really willing to pay the contractors the amount of money it costs to spend that much time at the site, because you're not out there adjusting it on a monthly basis, which unfortunate as it is, doesn't happen a lot of times anyway. You're out there at minimum adjusting on a weekly basis. So there's a lot of on-site time for the contractor. There's a lot of data, for them to go gather the weather data and to out the precip from the ET numbers and get that all put into the controller. So can it happen? Yes. Does it happen? No, not really. So this really offers a better solution, especially if the return on investment is so low. It's really a good way to go.
Okay. So we've got a few here from Johnny. One of them is, how much time was spent on the management aspect? What tasks were involved in the management plan? Did your controllers automatically adjust the watering interval?
Yes, those controllers automatically adjust the watering interval. As far as your question goes on exactly how much time was spent from the contractor out there, I'm not sure. I didn't really keep tabs on them on how much time that they did spend out there. They had proposed a number to or had a contract with a charge in there for controller management to the property management company. So we kind of backed off on that. Brian, who's with ET Irrigation, we communicated quite often. So I knew they were out there often, but how often, I'm not sure.
Okay. He has another question here. Interval management done by controllers automatically or part of fine tuning?
If you're talking about days per week from that interval, that's done by the controller.
Okay. And then a couple more questions here. We've got a lot of good questions this time. Thank you all for participating. Another one from Johnny is, how did you manage installation of new plant material?
We didn't install any new plant material.
Okay. And then the last one here, how did you outreach to get participation? Can you show us some of your marketing materials?
For the pilot, we really didn't have to outreach. We were approached. We already had a relationship with the irrigation manager because they had some other properties in Aurora. So we had dealt with them on getting them some water use analysis for those properties. So it was really more of a conversation that just happened. We had been interested in starting a pilot program. We knew this property already because we had done some analysis there. We knew it was a good candidate. So there really wasn't any outreach for the pilot program. Our outreach for the rest of our incentive programs, including the new Smart Controller Rebate Program, we do that a couple ways: social media. We also have our newsletter that goes out with the water bills, and then our website. So we don't do a lot of direct outreach. I would say the most contact that we have is during our irrigation assessment program. That's really a venue that we use to talk to customers and try to educate customers on outdoor water use. And their report, we talk about our irrigation incentive or irrigation rebate options to them while we're there. And then when they get their report, they're also kind of reiterated in that. So that's most of our irrigation rebates is driven from that irrigation assessment program.
Okay, thank you. Got a couple more questions here too. Do you have day of the week water restrictions, and was there a variance for this project or for the pilot?
So for the last 2 seasons, we have not. So we have what we call normal conservation measures. And in our normal years, the normal conservation measures are you can water 3 days per week, but you can pick any 3 days you want. And from May through the end of September, you cannot water between 10 a.m. and 6 p.m. So that's in effect all the time unless we go into an actual drought stage. And for the last 2 seasons, we have not been in those. But in regards to your questions on variance, we do have a large property watering variance program for any property over 20,000 square feet. Excuse me. So we have had 2 residential properties that have very large lots join. but primarily it's commercial properties, HOAs, common space. The school districts are all involved. So for them, we have a variance program. And a little backstory to that, as long as we're doing okay on time.
Oh, yeah.
Okay. So a little backstory to that was Aurora has we didn't start doing irrigation plans review and really have an irrigation code until 2005. So prior to that, a lot of the systems were designed, or not really designed, but they were installed with very little regard to hydraulic needs. So a lot of these systems, to try to force them to 3 days per week, with the assumption that they get everything irrigated in one night so they can irrigate everything 3 times within a week, hydraulically, their systems just can't handle it. So we started a variance program which allowed those properties to, they apply, they get an allocation for that growing season. It's not tied to their water bill, it's just a program allocation. And they can water any day of the week they want. They still can't water between 10 and 6. The idea is that they break it up, maybe half the properties Monday, Wednesday, Friday, the other half's Tuesday, Thursday, Saturday. There's not a lot of teeth in the program. If they exceed their allocation, they can be removed from the program. They do get a monthly automatically generated email that goes to the landscape contractor and the property management company or the HOA board, depending on who's on the application, letting them know how they're doing so far in the year. And that allocation does get adjusted each month based on the weather conditions. And it's been a very successful program for us. And again, that's another one of these programs that takes very little staff time, but just the education part of it and the contractor and the property manager being on the same page and having an understanding of how they're doing in regards to outdoor water consumption has been a huge savings for us. So we do have a variance program. This property is in the variance, they are in the variance program, but the 3 days per week under normal conditions is any 3 days you choose.
Okay, thank you. We've got another question here. Was any drip in the pilot, point source drip or inline drip?
There was not.
Okay.
It was all spray irrigation, all turf irrigation. There was no drip as part of this program.
And then another question from David. So are you using only one brand of smart controller? From anything you have learned, do you suspect that most smart controllers would demonstrate similar results to what you saw with the one, i.e. Rockio Orbit, SkyDrop, Smart Rain, etc.?
Yeah, so this pilot was one controller. We wanted to stay as consistent as we could. We are seeing a variety of smart controllers come in through the incentive program. And what we've tried doing is not limiting it too much. Kind of what we've done with our incentive program, the limiting factor for us is that it has to be able to adjust the day intervals on its own. We don't allow weather-based controllers that simply adjust the percentage of runtime and still maintain that same 3 day per week schedule or 3 days per week, 3 times per day schedule. And the reason why we've adopted that is to stick more to the Irrigation Association's soil moisture bucket watering method for irrigation. Would they all perform the same? I haven't personally used enough different ones to really say. They all seem fairly similar. I think it really comes back down to the management side. If it's managed the same and fine-tuned, at least for that first season and maybe into that second season, I would imagine they'd all do fairly well, fairly similar. The weather data pulls aren't that different, which is really the driving factor behind them, because the behind-the-scenes calculations tend to be fairly similar, and the input allowances are fairly similar as well. And that goes all the way down to the lower-end $99 residential ones that are out there now have a lot of input options that are available, up to the high-end ones for the commercial side. So I would expect to see a similar performance.
Okay. Just got one more question popped up. Most do not adjust the interval automatically. Big problem.
Yeah, it is.
Any comments on that?
Yeah, it is a problem. At least in our opinion, it's a problem. Now, to say that you're not going to see a benefit with, one that doesn't adjust the interval, you probably will. But from a rebate standpoint, the nice thing with doing incentive programs is you have some control. So you can kind of drive the requirements. So we're able to set what requirements we want met. It's still not that hard to meet, even on the residential market side of smart controllers. So we really haven't had too many issues with it. They are available. They're not really any more expensive. And I'm really hoping that everybody that's designing and building these smart controllers ends up going that route, because it really is it's the best way to irrigate, especially with turf.
Okay. Any more questions out there? Looks like we've had a lot of good questions today. I don't know, Tim, did you have some polls for the end of it, or?
I did not have any polls for any of
Okay.
it. I just wanted to say thank you to everybody that logged in to watch. And thanks for all the great questions. When we give this presentation, we tend to get a lot of questions. If you are in a municipality and you have further questions, after you kind of think about it for a little bit, don't hesitate to reach out. I'm always willing to have those conversations and see if what we've done can kind of help you guys as well.
Okay, thank you, Timothy. We appreciate you taking the time today to chat with us. I just wanted to give a little plug for our next month's Water Well with CWEL webinar. We'll have Faye Rudishauser and Josh Palmer. They're conservation coordinators from Utah Division of Water Resources, and they're going to be talking to us Tuesday, March 13th at 2 p.m. So thank you all for joining.
Wonderful.
Thanks, folks. Bye-bye.
Thank you.